This video will focus on the most general categorizations of matter, pure substances and mixtures. All matter in the universe can be defined as a physical substance that takes up space and has mass. Some everyday examples of matter include air, clouds, rock, wood, and the human body.
Whoa.
Energy, on the other hand, is a non-physical but quantifiable property of objects or particles. It can be transferred from one material substance to another and from one form to another. Examples of energy include heat, light, motion, sound, and chemical energy stored in the atomic bonds that hold molecules together. This diagram shows the categories of matter and gives examples for each subdivision. Pure substances can be either elements like oxygen and uranium or compounds like carbon dioxide and calcite. Both of these contain only one kind of matter. Elements such as carbon, gold, and mercury are substances at the atomic level. As such, an atom is the smallest unit possible that has the same properties as any amount of the substance. Atoms cannot be divided by standard physical or chemical processes such as milling or distillation, and any process that breaks atoms into fundamental particles changes the element into a different isotope or element. Compounds are the second type of pure substances and consist of two or more elements joined together by bonds. Compounds are chemically uniform, and this means they have fixed chemical compositions that do not vary either within the substance or depending on the amount of the substance. The fixed compositions of compounds are represented using chemical formulas. For example, the formula for carbon dioxide is CO2. This means that there are always 2 oxygen atoms for every 1 carbon atom in this compound. Other examples of compounds include table salt, which is sodium chloride, calcite, which is the main constituent of limestone and consists of the elements calcium, carbon, and oxygen, water, which consists of hydrogen and oxygen, and uranium dioxide, which consists of uranium and oxygen. Compounds cannot be physically separated into discrete parts or particles because they're held together by chemical bonds. Chemical reactions in which these bonds are broken result in compounds being separated into their constituent elements, and this would change the properties of the substance. For example, when table salt dissolves in water, the sodium and chlorine atoms separate and form electrically charged particles called ions. Pure substances are also defined by their characteristic properties, such as mass, melting and boiling points, electrical conductivity, and solubility. The terms compound and molecule have similar but not identical meanings. The difference is that a compound is always composed of 2 or more different elements, while a molecule can either be made of different types of elements, or it can be made of multiple atoms of the same element. There are diatomic, which is 2-atom molecules, that contain only one element, such as nitrogen gas, or N2, and there are a few triatomic molecules that contain only one element, such as ozone, or O3. These molecules are not compounds because they only contain one type of element. Nitrogen dioxide gas, or NO2, however, is a compound because it contains both nitrogen and oxygen atoms. We can summarize this discussion by saying that all compounds are molecules, but not all molecules are compounds. Now, moving to the right side of the diagram, we see that mixtures can either be homogeneous or heterogeneous. Homogeneous mixtures have a uniform chemical composition consisting of 2 or more substances and can be elements or compounds. In homogeneous mixtures, the combined substances are not rigidly bonded, but are mixed at an atomic or molecular level. This causes the mixture to behave as a single substance. Homogeneous mixtures can be referred to as solutions. What makes these distinct from compounds is that mixtures can be separated by physical means, including distillation, centrifugation, or crystallization. Some familiar examples of homogeneous mixtures are salt water, which is the compound sodium chloride dissolved in the compound water, air, which is a mixture of mostly nitrogen and oxygen gas, vinegar, which is a solution of acetic acid and water, natural gas, a mixture of hydrocarbons such as ethane and methane, and bronze, which is a solid solution or alloy consisting primarily of copper and tin. The second type of mixtures are heterogeneous substances. Now, these consist of physically separable parts, thus giving them a non-uniform chemical composition. Heterogeneous materials do not have regular physical or chemical properties because they're made of physically discrete substances. One way to think of it is if you took 2 sections or scoops from a heterogeneous mixture, it's most likely that they'll have different amounts of the constituent substances. A typical example of a heterogeneous mixture is fruit salad. This material consists of discrete parts, like apple, grapes, melons, or pineapple, that do not lose their individual properties when combined to form the mixture. They're still identifiable in the salad. Some other familiar examples of heterogeneous mixtures are granite, mainly consisting of discrete silicate minerals such as quartz, feldspar, and mica; mud, consisting of clay and silt particles and water; fruitcake, a delicious cakey material containing chunks of fruit; concrete, which consists of rock fragments embedded in cement; and sand, which is a physical mixture of mineral grains such as quartz or small rock fragments. Okay, let's review what we've discussed. Matter can be divided into pure substances and mixtures. Pure substances are chemically uniform materials with distinct physical and chemical properties such as mass, melting point, and boiling point. The two types of mixtures are homogeneous substances such as salt water and heterogeneous substances such as sand or mud. Homogeneous mixtures, also known as solutions, are chemically uniform, such as salt dissolved in water, while heterogeneous mixtures are chemically non-uniform, such as rocks and concrete. All right, before we go, let's go over a few review questions. Number 1. Which of the following materials is a pure substance? A. Champagne, B. A green glass marble, or C. A pool of mercury? The correct answer is C. Mercury is an element and is therefore chemically uniform. Number 2. Which of the following materials is a mixture? A. A nugget of gold, B. River water, or C. Helium gas? The answer is B. River water, which consists of silt and dissolved elements in water. Number 3. Which of the following mixtures is homogeneous? A. Slate, B. Soil, or C. Soda water? Soda water is a dilute solution of CO2 dissolved in water, which makes it a homogeneous solution. And that's all for this review. Thanks for watching and happy studying.